Assalamualaikum warahmatullahi wabarakatuh. My name is Favian Hanasta Permana. I'm from AP's Telecommunication Engineering Department. Now I will explain or I will present about the paper written by Giovanni Pau from Faculty of Engineering and Architecture, Korea University of Italy, with the title is Power Consumption Reduction for Wireless Sensor Network using a Fuji approach. Wireless sensor network is an ad hoc network composed of tiny devices with limited energy and computational resource. One of the technologies which is developed using wireless sensor network is environmental health monitoring. But there is the problem when we want to optimize the performance of the environmental health monitoring, such as the limitation of the energy. But to solve the problem, the authors use Fuji logic system in order to save the battery life of various sensor network nodes and to have an efficient, robust, and cost-effective sensing network. Cost-effective sensing network. The purpose Fuji logic system help efficiently to decide the situation for active sleep time of the processing and communication part of the sensor node. This is the network architecture from the authors. The network architecture is depicted and is composed by several environmental monitoring cells based on the IEEE 802.15.4 protocol. RFD nodes measure a physical parameter of the monitored environment such as temperature, humidity, or carbon monoxide, and then they send acquired data to their full function device node. It forward data received from RFD nodes to the FPG that process information and send appropriate common message to the sensor node. It is useful to note that IEEE, the transmission range varies considerably depending on the nature of the path that must be line of sight for the most part. Energy saving Fuji controller. In the purpose approach, the FFG node use a Fuji logic controller or FLC in order to calculate the new value of the sleeping time of each RFD. This is the scheme of power evaluation, the simulation. The aim of this scheme is to stimulate the behavior of the coordinator node and of sensor node. Sensor node will control the battery consumption of RFD node. Next. It is useful to highlight that the activities of the microcontroller and of a connected sensor have a low impact of the battery consumption. Where the battery consumption mainly depend on the working state of the device. When the device is sleeping, the battery consumption is 50 milliampere and 5 microampere. 5 microampere is the power consumption of the IEEE module in sleeping mode. This is the battery management. When the device is transmitting, the transmission power heavily affect the energy consumption. The battery consumption trend is evaluated in relation to the sleeping time by means of simulating or state flow environment. This tool uses flowchart and finite state machines in order to represent the evolution of a system. This is the result without VLC and proposed approach. This is throughput workload behavior on the star topology, and this is the throughput workload behavior on cluster topology. On the contrary, the values obtained without VLC fluctuate from 75% to 30% and 84% to 42%. In the star and cluster topology, respectively, representing the best result in terms of the ratio of throughput workload, but at the expense of the battery consumption. However, it is necessary to note that the value obtained with the proposed VLC are acceptable, especially in those application field with a moderate variation of data. As much as possible, the battery lifetime rather than to ensure high throughput workload performance. The conclusion of the paper is VLC can be used such a way as a further reduce the energy consumption in wireless sensor network. In fact, a Fuji-based approach presented in this work dynamically changed the sleeping time in order to increase the battery duration of the sensor device. Using the proposed VLC and substantial reduction of the energy consumption is obtained compared to simulation carried with fixed sleeping time. The results have been obtained using the Gaussian membership function because an improvement of 30% has been achieved compared to the approach without VLC. Thank you for watching and thanks for your attention. Wassalamualaikum warahmatullahi wabarakatuh.